I got breaking news coming in. Friedberg, your life's work. Sachs did his product review. Now it's your turn, Friedberg. We got breaking news coming in.
I did promise you that when Ohalo decides to come out of stealth and explains what we've done and what we're doing, I would do it here on the All In Pod first before the
All In exclusive.
All In exclusive. So basically, by the time this pod airs, we're going to be announcing what Ohalo's been developing for the past 5 years and has had an incredible breakthrough in, which is basically a new technology in agriculture. And we call it boosted breeding. I'm going to take a couple minutes just to talk through what we discovered or invented at Ohalo and why it's important and the kind of significant implications for it. But basically, 5 years ago, we had this theory that we could change how plants reproduce. And in doing so, we would be able to allow plants to pass 100% of their genes to their offspring rather than just half their genes to their offspring. And if we could do that, then all the genes from the mother and all the genes from the father would combine in the offspring rather than just half the genes from the mother and half the genes from the father. And this would radically transform crop yield and improve the health and the size of the plants, which could have a huge impact on agriculture because yield, the size of the plants, ultimately drives productivity per acre, revenue for farmers, cost of food, calorie production, sustainability, et cetera. So this image just shows generally how reproduction works. You've got two parents. You get a random selection of half of the DNA from the mother and a random selection of half the DNA from the father. So you never know which half you're going to get from the mother or which half you're going to get from the father. That's why when people have kids, every kid looks different. And then those two halves come together and they form the offspring. So every time a new child is born, every time a plant has offspring, you end up with different genetics. And this is the problem with plant breeding. Let's say that you have a bunch of genes in one plant that are disease resistant, a bunch of genes in the other plant that are drought resistant, and you want to try and get them together. Today, the way we do that in agriculture is we spend decades trying to do plant breeding, where we try and run all these different crosses, find the ones that have the good genes, find the other ones that have the good genes, and try and keep combining them. And it can take forever, and it may never happen that you can get all the good genes together in one plant to make it both disease resistant and drought resistant. So what we did is we came up with this theory that we could actually change the genetics of the parent plants. We would apply some proteins to the plants, and those proteins would switch off the reproductive circuits that cause the plants to split its genes. And as a result, the parent plants give 100% of their DNA to their offspring. So the offspring have double the DNA of either parent. You get all the genes from the mother, all the genes from the father. And finally, after years of toiling away at trying to get this thing to work and all these experiments and all these approaches, we finally got it to work. And we started collecting data on it. And the data is ridiculous. Like the yield on some of these plants goes up by 50 to 100% or more. Just to give you a sense, like in the corn seed industry, breeders that are breeding corn are spending $3 billion a year on breeding, and they're getting maybe 1.5% yield gain per year. With our system, we are seeing 50 to 100% jump in the size of these plants. It's pretty incredible. Here's an example. This is a little weed that you do experiments with in agriculture called Arabidopsis, so it's really easy to work with. And you can see that what we have on the top are those two parents, A and B, and then we applied our boosted technology to them and combined them, and we ended up with that offspring called boosted AB. So you can see that plant on the right is much bigger, it's got bigger leaves, it's healthier looking, et cetera.
Friedberg, can I ask you a question? Does that mean that the boosted one has twice the number of chromosomes as A and B?
Exactly right.
So is that like a new species then?
Yeah, so it's
how does it survive with twice the number of chromosomes?
Yeah, it's called polyploidy. So we actually see this happen from time to time in nature. For example, humans have 2 sets of chromosomes, right? So does corn, so do many other species. Somewhere along the evolutionary history, wheat doubled and then doubled again, and you end up actually in wheat having 6 sets of chromosomes. Wheat is what's called a hexaploid. Potatoes are a tetraploid. They have 4 sets of chromosomes. And strawberries are an octaploid. They have 8. And some plants have as many as 24 sets of chromosomes. So certain plant species have this really weird thing that might happen from time to time in evolution where they double their DNA naturally. And so what we've effectively done is just kind of applied a protein to make it happen and bring the correct two plants together when we make it happen. And so
this could only happen for a plant, right? This could never happen with an animal.
It wouldn't work in animals. It works in plants.
Okay.
And one way you can think about plant genetics is all the genes are sort of like tools in a toolbox. The more tools you give the plant, the more it has available to it to survive in any given second, to deal with drought or hot weather or cold weather, etc. And so every given second, the more tools or the more genes the plant has that are beneficial, the more likely it is to keep growing and keep growing. And that plays out over the lifetime of the plant with bigger leaves and bigger, grows taller. But more importantly, if you look at the bottom, the seeds get bigger. And in most crops, what we're harvesting is the seed. That's true in, corn and many other crops. And so seeing over a 40% increase in seed in this little weed was a really big deal. But then we did it in potato. And potato is a crazy result. Potato is the third largest source of calories on Earth. And so we took two potatoes that you see here in the middle, A, B, and CD. We applied our boosted technology to each of them, and put them together, and you end up with this potato A, B, C, D. That's the boosted potato. And as you can see, these were all planted on the same date, and the boosted potato is much bigger than all the other potatoes here, including a market variety that we show on the far right. That's what's typically grown in the field. Now, here's what's most important. When you look under the ground and you harvest the potatoes, you can see that AB potato only had 33 grams. CD had 9 grams. So each parent had 33 and 9 grams potato. But the boosted offspring had 682 grams of potato. The yield gain was insane. And so you could see this being obviously hugely beneficial for humanity. Potatoes being the third largest source of calories, Indian potato farmers are growing 1 acre of potato. In India, they eat potato 2 meals a day. In Africa, potato is a food staple. So around the world, we've had a really tough time breeding potatoes and improving the yield. With our system, we've seen incredible yield gains in potato almost overnight. And the other
how big are those potatoes?
Those are normal sized potatoes that you see there. Those are like, table potatoes. Basically, that looks like a russet potato right there. That's like a normal size russet.
I can tell you,
it started
got
as like a
something
little.
right.
It started as like a little creamer potato, basically, and you blew it up into a russet potato. Is that?
Yeah. So the genetics on AB, you can see they're like tiny little purple potatoes. The genetics on CD are like these little white, tiny little ball potatoes. But when you put those two together with boosted and you combine all the DNA from AB and all the DNA from CD, you get this crazy high yielding potato, ABCD, which by the way is higher yielding than the market variety that's usually grown in the field on the far right.
So why not just grow russet potatoes then?
We are. And so we're working on doing this with russet. We're working on doing this with every major potato line. Sorry, the improvement you'll see is actually in yield. So it's not the size of the potato, it's the number of potatoes that are being made. And so you'll
per
see
hectare acre or something like that, like the dwarf wheat, projects in the 60s and 70s. Shamath, you know how you can tell Friedberg's onto something here? You got David Sachs to pay attention during it. This is going to be a decacord if Sachs is awake. Sachs is like, how do I wet my beak?
Sachs is interrogating the potato lines. I've never.
What's going on?
I think genetics is interesting. But so have you tried these potatoes? Do they taste different?
Oh, no, they're awesome. Yeah, they're potatoes. And we do a lot of analysis.
You haven't sprouted any horns yet or anything like that?
No. Again, one of the other advantages of the system that we've developed, let me go back here. And I just want to take 2 seconds on this. One of the other things this unlocks is creating actual seed that you can put in the ground in crops that you can't do that in today. So potatoes, the third largest source of calories. But the way we grow potatoes, you guys remember the movie The Martian, you chop up potatoes and you put them back in the ground. Because the seed that comes out of a potato, which grows on the top in the flower, every one of those seed is genetically different because of what I just showed on this chart, right? You get half the DNA from the mother, half the DNA from the father. So every seed has different genetics. So there's no potato seed industry today. And potato is like $100 billion market. With our system, not only can we make potatoes higher yielding and make them disease resistant, what we also make is perfect seed. So farmers can now plant seed in the ground, which saves them about 20% of revenue, takes out all the disease risk, and makes things much more affordable and easier to manage for farmers. So it creates entirely new seed industries. So we're going to be applying this boosted technology that we've discovered across nearly every major crop worldwide. It'll both increase yield, but it will also have a massive impact on the ability to actually deliver seed and help farmers and make food prices lower.
Is it
and
more
improve
expensive?
Sustainability. No, it's actually cheaper. So higher yield, lower cost.
Do you need more water?
Less water, less land, less energy.
Do you need more fertilizer?
Fertilizer usually scales with biomass, but these sorts of systems should be more efficient. So fertilizer use per pound produced should go down significantly as we get to commercial trials with all this stuff. And we're doing this across many crops. So there's a lot of work to do in terms of like, how do you scale
and tell
the
us
production
about,
in the fields?
Tell us about the patents and how important patents play a role in this, because isn't it like one of Monsanto's big things, like they just go and sue everybody into the ground or whatever? Like,
I'm going to answer you 1 second. I'm just going to switch my headset. It just died.
Wow, we went from Sachs's bots to Friedberg's crops.
I'm glad we're doing him second, because all of a sudden, like, group chat doesn't seem very important.
Yeah, wow. He just solved the whole Ukraine crisis here. We're going to be able to grow wheat in the desert and in the rainforest.
He solved the world food problem.
Yeah, Sachs. What did you do for the last 6 months?
Yeah, we made enterprise chat a little better, but
we added AI to enterprise chat. We cleaned up your Slack.
So yeah, when you invest, we've invested a ton of money. This was stealth for 5 years. We put a ton of money into this business. So when you invest like, north of 50, north of 50. Yeah.
50 million, 5 years, and you don't have a product in market yet. Wow, that's some deep
we
tech.
actually have some product. Yeah. So I haven't talked about the way we've been making money in some of the business we've been doing.
Oh, okay.
Let me just make sure this is like clear. So that last photo you showed with the different types of potatoes, you had created the super huge ones, but you're saying that the yield benefit here is just you create a much bigger, hardier plant that's capable of producing
many more potatoes. Yeah.
But the size of the potatoes doesn't change?
You can control for that when you breed. So the selection of what plants you put together in the boosted system allows you to decide, do you want small, medium, large? That's all part of the design of which plants do you want to combine.
Okay, because your goal is not to turn like a russet potato into like a watermelon or something like that.
No, the goal is to make more russet potato per acre so that we use less water, we use less land, farmers can make more money, people pay less for food. That's the goal. And so it's all about yield. It's not about changing the characteristics. There are some crops where you want to change the characteristics, like you might want to make bigger corn kernels and bigger cobs on the corn, which is another thing that we've done. And that's actually been published in our patent. And the reason, by the way, I'm talking about all this is some of our patents started to get published last week. And so when that came out, the word started to get out. And that's why we decided to get public with what we've done, because it's now coming out in the open.
You mentioned something briefly there about where different crops can be planted. You know, we had these big talks about wheat and corn. They're only available in very specific parts, you know, north of the equator. They can't be in jungles, can't be in obviously polar or desert extremes. So if you're successful, what would this do for, on a global basis, where these crops are made? Because remember this whole discussion about Ukraine and like the wheat belly of Europe, the cradle of wheat. Yeah,
it's a great question. I'm so glad you asked it, because that's one of the key drivers for the business, is that we can now make crops adapted to all sorts of new environments that you otherwise can't grow food. Today, there's close to somewhere between 800 million and 1 billion people that are malnourished. That means they're living on less than 1,200 calories a day for more than a year. But on average, we're producing 3,500 calories per person worldwide in our ag systems. The problem is we just can't grow crops where we need them. And so by being able to do this sort of system where we can take crops that are very drought resistant or can grow in sandy soil or very hot weather and adapt cooler climate crops to those regions, but through the system, we can actually move significantly where things are grown and improve food access in regions of need.
How, Friedberg, when you look at a potato, how do you figure out what part of their DNA is the drought-resistant part?
Yeah.
And then how do you make sure that that's turned on? So even if you inherit that chromosome, is there some potential interaction with the...
Generally, if we can... So these are what are called markers, genetic markers. And so there are known markers associated with known phenotypes. A phenotype is a physical trait of a plant. And so we know lots of markers for every crop that we grow. Markers for disease resistance, drought resistance, markers for big plants, short plants, etc. And so what we do is we look at the genetics of different plants that we might want to combine into the boosted system. And we say, these ones have these markers, these ones have these markers. Let's put them together. And then that'll drive the results. One of the other interesting things we're seeing, which I didn't get too much into in the slides, it's not just about combining traits, but it turns out when you add more genes together, biology figures out a way to create gene networks. These are all these genes that interact with each other in ways that are not super well understood, but it makes the organism healthier and bigger and live longer. This is like when you bring, like why mutts are healthier and live longer than purebred dogs, because they have more genetic diversity. So there's a lot of work now in what's called quantitative genomics, where you actually look at the statistics across all the genes. You use a model, and the model predicts which two crosses you want to make out of hundreds of thousands or millions of potential crosses that the AI predicts. Here's the two best ones to cross, because you'll get this growth or this healthiness
So
factor that'll emerge.
how do you want to make money, Friedberg? Are you going to sell the seeds? Are you going to become the direct farmer? Are you going to become food as a service? Like, how do you make the most money from this?
We're not going to farm. Farmers are our customers. And so there are different ways to partner with people in the industry who already have seed businesses or already have genetics and help them improve the quality of their business. And then there's other industries like in potato where we're building our own business of making potato seed, for example. So every crop and every region is actually quite different. So it becomes a pretty complicated business to scale. We're in the earlier days. We're already revenue generating.
I would like a sweeter blueberry.
No comment. No comment. Yeah.
I get tilted by the quality of the Driscoll's blueberries.
Let me tell you something about the Driscoll's blueberries.
Also, the Driscoll, I've had only one batch of a Driscoll strawberry that was just off the charts. And every 19,847 other batches I bought have been total shit.
Yeah.
Now you want the European small ones or the Japanese
those
ones
are
from
great. Matt loves
Hokkaido,
those, yeah.
because they're
Yeah.
rich and sweet, and they're not these like monstrosity of giant flavorless strawberries. What's that about, Friedberg?
Could you do a seedless mango?
Yes, you
Nope.
can cut it.
So you
Help
can
us
just
out
cut
here,
it.
Friedberg.
Oh my God, how great would that be?
The
Spoon it
amount of
out.
work per
Oh,
bite on a mango
God.
is like the
Oh.
worst ratio.
Yeah.
Oh my God.
Well,
Somehow we made it about us.
yeah, no, look, I think it is all about you guys.
So
'Cause
tell us about the blueberries. Sorry.
Well, no,
Strawberries,
every
sure.
year Driscoll's puts out a special labeled package called Sweetest Batch. And they just had the sweetest batch of strawberry and blueberries. I don't know if they're still in the stores, but they only last for like a week or two. And that's the best genetics, only grown on a small number of acres.
What?
Really incredible.
I'm going to Sedona
blueberry.
as soon as this is done.
Yeah. See if they have it still. I got it a few weeks ago. It's quite delicious. Anyway, let's just say we know the berry market very well. My co-founder, CTO, Judd Ward, whose brilliant idea boosted breeding was many years ago, who I met because they had a New Yorker article on Judd. I cold called him and said, hey, will you come in and give us a tech talk? We started talking, and Judd came up with this idea for boosted breeding. And so we started the business with Judd, and Judd ran molecular breeding at Driscoll. So we have a lot of Driscoll's people that work at Ohalo. We know the market really well.
Can you go back to the patent stuff? Like, are you?
Oh, yeah, sorry,
Will
that was the
some
question.
seed person?
So
sue
we've
you?
spent $50 million on, plus on this business to date. So we have filed for IP protection so that people can't just rip us off. But I would say, I think that the real advantage for the business arises from what we call trade secrets, which is not just about taking patents and going out and suing people. That's not a great business. The business is, how do you build a moat? And then how do you extend that moat? The great thing about plant breeding and genetics is that once you make an amazing variety, the next year the variety gets better, and the next year the variety gets better. And so it's hard for anyone to catch up. That's why seed companies generally get monopolies in the markets, because farmers will keep buying that seed every year, provided it delivers the best genetics. And so our business model is really predicated on how do we build advantages and moats and then keep extending them, rather than try to leverage IP. So I'm a big fan of like building business model advantages.
This is going to be incredible, Sachs. If you think about, geopolitically, what's going on in Somalia, Sudan, Yemen, Afghanistan, those places have tens of millions of people, I think hundreds of millions collectively, who are at risk for starvation. If you could actually make crops that could be farmed there, Friedberg, you would change humanity. And then all these people buying up farmland in America, that could devalue that farmland if that wasn't as limited of a resource. Yeah, Friedberg?
No, I think, so first of all, like farmland in America is mostly family owned. It's about 60% rented, actually. So a lot of families own it and then they rent it out because they stop farming it. But the great thing that we've seen in agriculture historically is that the more calories we produce, the more food we produce, the more there seems to be a market. It's like any other economic
What about
system.
wheat and rice?
Yeah. So those are calorie sources 1 and 2. And there's certainly opportunity for us to apply our boosted systems there. The big breakthrough with potato is we can make potato seed using our boosted system in addition to making better potatoes.
McDonald's is the largest buyer of potatoes, yeah?
So in the US, 60% of the potatoes go to French fries and potato chips. McDonald's buys most of the fries. PepsiCo under Frito-Lay buys most of the potato chip potatoes. 40% are table potatoes. In India, 95% of the potatoes are table potatoes. They're eaten at home. And the Indian potato market's 3 to 4 times as big as the US potato market. In Brazil, it's 90% table potato. So all around the world, potatoes different. The US is, unusually large consumers of French fries and potato chips.
I speak on behalf of JCal when I said we will gladly invest $1 million at a 10 cap in both of your businesses.
Absolutely. Yes, we will grift our way into this.
JCal and I will do the deal. We'll wire the money. We'll wire the money. A little million to each of you guys at a 10 cap. Thank you.
Absolutely.
You're in. It may not be a 10 cap though, but yes.
Breaking news.
You're in.
Chamath and JCal have secured the bag. That's the breaking news. Chamath and JCal have secured the bag from the besties actually doing work.
Yeah. Well, I appreciate you guys letting me talk about it today. I'm excited to share it.
To both of you. I love it.
It's been, building
so great,
stuff
guys.
is hard. There's always risk. It's a lot of work and a lot of setbacks. But man, when you get stuff working, it's great.
We're each doing the things we do best. Friedberg is solving the world's hunger problem, and I'm cleaning up your Slack. Right? Making your enterprise chat a little better.
All progress counts, Zach.